All right, guys, today we're going to be talking about absolute value functions and their graphs. And so I went ahead and took the liberty of going ahead and getting on Desmos here and graphing y equals the absolute value of x for us, just so that you could see that visually. And we're going to talk about why this is the shape it is, and then what comparisons that we can make to what we've already understood about transformations of graphs and how that works. So first of all, look at this. If you'll notice, every point along this line has a positive y value or an output value. Remember, y is your outputs, x is your inputs. So for every value of x that I am putting in, even if my x's are negative, like along this direction, I still get a positive y. And so I want you to think for just a minute about why that is the case. Okay, so when we're talking about absolute value, we know that absolute value is distance from zero, and we know that distance from zero can never be negative. And so it makes perfect sense then why that if I do the graph of y equals x, the absolute value of x, that I'm going to have positive values. And this will make a little bit more sense if we look at maybe some points that are along this. So again, if I put -2 in for the x value, then the absolute value of -2 is still 2. If I put in -1 as my value for x, I'm still going to get the absolute value of -1 is 1. So you can see that all these values are positive no matter how I go about that. So that is why that this goes up in the direction that it goes. Now, what I would ask you to think about as well is I wonder if the same principles that apply to the graph of the quadratic that we looked at yesterday apply to absolute value functions and their graphs. So what I'm going to do, I'm going to go ahead and do this again. Y equals absolute value of x. And yesterday we learned that if you put a negative out to the front of something, then that becomes a reflection. So let's see what happens here. If I put a negative right there, look what takes place. I have exactly the opposite trend going on. I have the same exact shape. And if you're a cheerleader, I don't know how many of our students are cheerleaders, but if you are, then you recognize two poses here. You recognize the high V and the low V that are the basic cheers of cheerleaders. As a matter of fact, if we were in class in person, I would probably get up in the room and I'd do some cheers for you and have some volunteers. It would be pretty funny, as a matter of fact. But again, you get the idea here that by putting that negative, I am getting a reflection. So at least that part is held true so far. Now let's see, if I put a value out here, like for example, +2, what kind of change is that? I'm going to quiz you just a little bit. If I put a value out to the right of this, then that denotes a vertical change. So it should go up 2 units, right? Because a vertical change is literal. So you notice +2, look what happens, it goes up 2. So good, so far so good. So let's do another example. Let's put in here a -1. Now, before I do it, tell me what you think is going to happen here. Just think about it for just a second. Again, this would denote a horizontal change, and we said that the horizontal change is opposite of the way we think. So if I put in a -1, notice what happens. My graph, based on the parent graph, actually moves over one value. Okay. So what about a stretch or compress? Let's try that. So I'm going to back this back out. And remember, if I wanted to stretch this value, A has to be greater than 1. So I'm going to put in a value of 2. And look what happens. Lo and behold, it does and behaves exactly the same way. As a matter of fact, I'm going to go ahead and erase this out and put in 1/2. And look what it does. It begins to flatten out or compress. And so we see from this illustration that it performs exactly the same way. We'll come back to these graphs here in just a second, but I want to switch over to a reteaching sheet and just show you this format again and show you one more principle here. So if you look, it says a function of the form y equals a absolute value of x minus h plus k is an absolute value function. Boy, that looks very, very familiar. It's exactly like what we had before. The only difference is we don't have parentheses and we don't have squared. It's not quadratic, but again, we do have the same exact things in here. The same exact h, the a, the k, everything's all still there, the same players. So then it says the graph of y equals a, absolute value of x minus h plus k, is an angle, which we already figured out. It looks like the high V. And its vertex is located at the point. Now, this is very, very important. Its vertex is located at the point h and k. So h and k in our formula actually denotes where the vertex is, okay? So that is very important because when we get to talking about parabolas later, as a matter of fact, when we get talking about circles, this is going to come back into play again. You're thinking circles, yeah. When we talk about the equations of circles, this h and k is going to come right back again. And so you're going to hear this terminology again and again. So I'm going to jump back to the Desmos screen again because I want to show you what we're talking about basically. So again, if we look at this graph here, you will notice that my vertex, again, a vertex is where two angles, two rays extend from one point. So the vertex of this is 0, 0. Well, look what happens when I add in some translation. So I'm going to add in -1, +3. Notice what happens. Of course, it behaves like I think it should. I've got a +3 out here, so that's a vertical change of 3. Well, this went up 3. And you also notice that I have a horizontal change. Now, remember, horizontal change is opposite. So it says -1, but it should actually go to the right one. Well, that's exactly what it did. And here's what I want you to notice. Here's my vertex point here, right? Notice what my vertex is here. My vertex is the value for h. Remember, I'm not worried about that negative. That negative is part of the formula. It's the value for h right here, and it is my k value. So interestingly enough, my vertex, I can see from this format without actually having to graph this. I just wanted to graph it so that you could see visually what's happening. So this right here and this right here denotes my vertex. Now, another thing that we have to talk about is we have to talk about something called the axis of symmetry. Okay, and that's going to sound really confusing right now, but let's work through an example. As a matter of fact, we'll just look at this one here real quick. So what I want you to realize is, you notice I got the y-axis that goes right through my parent graph. Imagine, if you will, if I were to spin this, like this was a stick or a pole, and I decided to spin my graph around like this, okay? This side, if I spin around, would end up exactly in the same place as this one, and this one would end up on that one. Okay, so I want you to imagine there is an imaginary line that goes right through the middle of this graph. Well, that is called your axis of symmetry. In other words, if you were, again, to spin that graph, that it would end up in exactly the same position again. Well, what I want you to notice is, on this particular one here, I want you to imagine that there is a line right through here, right through the middle. As a matter of fact, you know what? I'm going to go ahead and put that line in there. So if I put in x equals 1, you see this line that's here, right? So what I want you to see is if I spin this graph around, this line should end up exactly on this line and vice versa. So this becomes my axis of symmetry. So what I want you to notice is, notice where my line is. It's at x equals 1. And so my axis of symmetry is very simply just where my h value is. Notice that the h value, again, or the vertex right here, was 1. So my axis of symmetry is just very simply x equals 1. We'll put that in there again for you so that you can see that. X equals 1 right there. It goes right through the middle. It becomes my axis of symmetry. So let's look at a live example here. I think this will help us maybe to get where we need to get to. It says compare y equals -3, absolute value of x plus 1 plus 2 with the parent function f of x equals absolute value of x. Now notice this. It says without graphing, find the vertex, axis of symmetry, and transformations. So let's think first of all about the vertex. Remember, this is already kind of written in the format that I need. So I'm going to go ahead and write that out again. Y equals plus or minus a x minus h plus k. Notice all of my values are right below my letters, and so we already understand that our vertex is very simply h and k. So in this case, I have a positive 1 here. Now remember, there's already a negative in the formula. So if this is positive 1, what would h would have originally had to have been? My h would have had to have been negative 1, okay? Hopefully that makes sense, because again, we got to think about this being the opposite. If this says positive 1, we have to know that because that negative is in the formula, that this is always going to be opposite. Now, what about my k value? Well, my k value, very simply, is just a positive 2. So it would just be a positive 2. So believe it or not, that right there would be my vertex without even graphing. Okay, I can see that that would in fact be my vertex. As a matter of fact, I'm going to go over, switch back over real quick, and I'm taking you back and forth a whole lot. But let's go ahead and put in that problem. So we had negative 3. We had x plus 1. And then we had plus 2. Notice what happens. You're going to see some things right off the bat, some transformations that are taking place. Well, what I want you to notice right now is your vertex. Notice right there, our vertex, negative 1, positive 2, which is exactly what we said it was going to be just by looking at the form, okay, without even having to graph it. Now let's talk about our axis of symmetry. Well, again, our axis of symmetry, looking back at our graph, is this imaginary line that goes through the middle of the graph. Well, where would that imaginary line be? Well, it's going through x equals negative 1. Again, if I were to look at an imaginary line going up through there, it is x equals negative 1. So very simply, once I find my vertex, I know what my axis of symmetry is going to be. And so my axis of symmetry, I'm going to abbreviate that as AOS, is x equals negative 1. It's whatever this h value is right here, okay? Whatever this value is, that's what your axis of symmetry is going to be. Now let's talk about the transformations. Well, first of all, I have a negative. So instead of this graph pointing upward, I know that it's going to be pointing downward, again, without even having to graph. Now, we've already graphed, so you've got a kind of an idea of what you're looking at. But we know that it's going to be pointing downward. What else do we notice? We notice that we have a 3 where our A term is. So what does that mean? If I have a 3 right there, does that mean a stretch or a compress? Well, this number is greater than 1, which means that it's going to be a stretch, right? I also see that I have a horizontal shift. It says positive 1, so I know that actually means it's going to go to the left 1 because it's opposite. And then I also have a positive 2 right here. So again, let's look at our graph. Against the parent graph, it's pointing downward. It is very much more stretched. It's pulled in tighter. You will notice as well that I have shifted to the left 1. Even though I have positive 1 right there, I have negative 1 here. And you'll notice that it is also shifted vertically up 2 units. Okay, so all of those would be descriptions that we would have about this particular problem. Let's look at another live example, and then I've got one more problem after that, and then we'll be done for today. So it says, without graphing, identify the vertex, axis of symmetry, and transformations from the parent function. And we might as well pick one of the hardest ones here. So number 9, right here. So again, I want to talk about the vertex. Well, again, my vertex is, right here, my vertex is h and k, right? So if I look at my format, and again, I'm looking at this against what I already know, and I'm going to write it up here again, plus or minus a, x minus h, plus k. You're going to get that in your head by the time this is all said and done. If I look at this, I see that I have a positive 1 right here. Now again, what do we already decide? If this is a positive 1, we know that it has to be the opposite. So my vertex is going to be negative 1, and my k value is a negative 3. So that means my vertex is going to be negative 1, negative 3. Now for my axis of symmetry, again, I know that it's going to be my h value. So my h value here is a negative 1. So I know my axis of symmetry, or my line of symmetry, if I want to call it that would be x equals negative 1. I want to imagine that little imaginary line that goes up through x equals negative 1. And last but certainly not least, let's talk about the transformations. So we don't have a reflection, so we would know that this graph is pointing upward. We do have a 2 in the place of a. So again, this would be a stretch because it is greater than 1. I know that I have a horizontal transformation, a horizontal shift, and instead of it going to the right 1, it would be -1, so to the left 1, and then vertically I would have a shift down of 3 because it's a -3. Again, if you did well on the assignment from yesterday, then you're going to do well on this one because it's really just mirror images again of what we've already seen. Okay. Last but certainly not least, I want to show you the other part of this assignment that you're going to have. And so what you're going to be given is you're going to be given a graph a lot like this one here. Sorry, that's a little bit out of focus. Let me try to fix that a little. You're going to be given a graph like this, and it's going to ask you to come up with the absolute value equation for this particular graph. Okay? So the first thing I would want to do and want to think about is the fact that my vertex is right there, because my vertex tells me so much about this particular graph. Okay? Now let's go ahead and write out our format, and then we'll fill it in. Okay? I keep wanting to write parentheses instead of the absolute value bars. Okay, so there we go. Y equals plus or minus a, absolute value of x minus h plus k. Let's try to settle this first. Do we have a vertical change? In other words, does this graph move up or down above the x-axis, or is it right on the x-axis? Well, if you notice this graph, the vertex is right on the x-axis, which means that I am not shifting up or down at all. So that means this is plus 0. Well, we all know that plus 0, if I add 0 to anything, I've not really did anything to it, right? So it's not really necessary, but I wanted you to at least see that that would be plus 0, okay? Now let's think about the fact if we have a horizontal shift or not. You notice that my vertex is not on 0, 0, but as a matter of fact, it is over to the left 2 units, okay? So remember, knowing that horizontal changes are actually opposite of what you think, even though it went -2, that would mean this would have to be x plus 2, okay? Again, horizontal changes are opposite, so the fact that it moved left 2 means that I would have to have positive 2 because I've already got a negative in my formula. Now let's think about whether this is a stretch or a compress. So what I want you to do, I want you to think about this kind of in terms of slope, and I want you to really look at this from a standpoint of just looking at one side, okay? So I'm going to cover this part up with my phone right now, okay? And I want you to just think about the slope of this line right here. So again, we need to find a point where I can go up and over and figure out what this slope would be. So if you notice, if I go up 1, it's kind of hard to find somewhere that intersects exactly at a crosshair, if you will. But if you look right here, you can kind of see that there's a point right there, okay, where we meet at an axis. So I know if I can get my rise and my run, I'll have this figured out. Because whatever it does on this right side, it's also going to do on the left side. But I'm just putting my phone here just to try to focus on just this right-hand line. So what I want you to notice is I have to go up. So it's rise over run to find slope. So I'm going to go up 1, 2, and then I have to go over 1, 2, 3. So again, I went up 2, or I rose 2, which is positive, and I went over to the right 3 units, which is also positive. So it's almost like slope, and I'm careful about saying that because when we get to quadratics, it works a little bit different. But our slope, if you want to say it that way, of A, or a stretch or compress, is 2 over 3. Okay? Now let's think about this. This is pointing upward. So do I have a reflection here from the parent graph? Well, not really, because it would be pointing down, right? So this would continue to be positive, and I've still got y equals. So last but certainly not least, we can clean this up a little bit. Y equals, I don't really need to put the positive because that's understood to be there, 2/3 absolute value of x plus 2, and I don't really need to put the plus 0 because it doesn't add anything to the problem. So right here is the equation that would need to go in for that particular graph. And in your case, you're going to just be able to choose from 4 options because it's multiple choice. But again, I just wanted you to understand how that you go about doing that. Hopefully, again, this has been helpful. If you have any questions or concerns, feel free to let us know. We'll do our very best to try to help you out.